So thank you for coming to my talk. I have to say I was a little bit concerned about security, that I've just been sort of wandering around as an unidentified person, eating for free, sort of gobbling up resources with no badge, but it just shows how friendly everyone here is. So my name is Aileen Nielsen. I am a software engineer and sort of jack of all trades at OneDrop in New York City. We are a super lean, super small diabetes management platform, and our goal is to sort of revolutionize the idea of the quantified self in treating chronic illnesses like diabetes. So I'm happy to talk to people about that, but not during the talk. Okay, so the title of my talk is NoSQL Python. Why, other than the trendy name, right? NoSQL is a buzzword. You are probably coming with this with all sorts of expectations that are going to not be fulfilled, but I kind of wanted to grab your attention and present sort of my version of why I care about NoSQL. So first, I'll be telling you why I picked that title and why this matters to me. Secondly, a little bit of how, just sort of nuts and bolts. This is actually, I'll warn you now in case you want to head out, it's sort of the nitty-gritty of dealing with nasty file formats and things like this when we're not using nice, clean SQL data. And then finally, going back to the why again, hopefully in a sort of more compelling, data-driven way rather than my just editorializing. So the why. Let's start with standard SQL-like tidy data. How many people know this buzzword tidy? This is very popular in the R community, but I think it's also making its way over to the Python community, and for good reason. So what makes this data tidy? There's a few things. First, the observations are in rows. Every individual observation gets its own row. We don't do any sort of polluting one row with another. We don't want to have many, many columns. That's part of the idea of tidy. Only your variables are in columns, right? Something that can be different. And it's contained in a single data set, and I think we all like that, right? We want all our data in one place, readily accessible. Can you tell me anything useful about this data set? Quick. What do you see? Okay, not fast enough. I will tip you off a bit and say maybe if you look here, you'll see something useful. What useful info do I have? Okay, what's the high score? 25. What's the low score? How many people? Oh, there's a big delay, right? How many days? Big delay, right? Let's switch it up. So these things are easy to see. The high score, the low score, the total observations. That one is sort of easy to see, right? That's never going to be that easy. Not so easy, though, are things like how many people, who's doing the best once you realize there's repeats, right? Who's doing the worst, and how is a particular individual doing, right? So let's say I'm a grade school teacher. These are some of my students and some of their scores. If I'm storing my data this way, that's not fantastic, right? I don't have some sort of easy to access, easy to think about way of categorizing how my students are doing. Okay, I'm going to change it up a bit. I'm looking for a better format. What changed? My sorting, right? So now I'm sorting by day instead of by score. So what do I get now that's better? Well, at least one thing, right? How many days? That becomes clearer. So in case I forgot, because I've been so busy changing the world and changing these students' minds, I actually now remember how many days I gave tests on. But there's still a lot of things I can't see that I would say I can see really well when I do this. So this data is not tidy, right? So there might be people who are really mad right now. If you're really mad right now, you're probably not going to like most of what I do during this talk. And I've gotten yelled at by lots of people. You don't do this. This is terrible. This is dirty, dirty data. I don't like it. But I can eyeball it really easily, right? Like this is sort of how I want to be thinking about my students. How's Joe doing? Well, he went from a 1 to a 14 to a 17. That's fantastic. So new questions become interesting and easier to answer. Before, what you could tell me quickly was maybe the high score and the low score. Well, that's sort of interesting, but it's not terribly interesting when I want to know, say, how my child is doing if I'm talking to the teacher. New questions become interesting and easier to answer, I think, is the most important, because what I sometimes worry about is that the way we're storing our data is actually sort of affecting the questions we're asking and the questions we're willing to answer, right? And I think especially the latter. We've probably all had this experience. I have this experience every week. especially in a small startup where I am like the only person who touches the database, anything that's not sort of easy to answer, yes, it's an interesting question, but I can sort of feel myself being like, yeah, I'll get to that, but that one's complicated. And then if they ask me something that's really easy based on my format, I'm like, boom, and I send that to you in 5 minutes. And so to some extent, the company I'm working for is deeply, deeply influenced by how I've chosen to store my data. And I'm sure it's the same wherever you are working, that if it's easy to do and joyful to do, you do it quickly, and otherwise not so much. So some of the questions that now become easy to answer, how many students are there? Who improved? Who improved? Joe improved. Who missed a test? Alan missed a test. Who was kind of meh? Mary's kind of meh, right? She's sort of futzing around, no clear trend. Okay, so don't get mad. I'm not saying to kill the idea of tidy data, but I worry that we don't use certain methods or ask certain questions more often just because it's not as easy as it could be, given whatever data storage we've decided on. And here's some examples that in my experience and colleagues' experiences are not that easy to answer when you're working with a tidy mindset or a very strongly SQL mindset. In app analytics or game analytics, what usage patterns do we see in a long-term user, right? So I want to backtrack, look at a particular user, and see what he did each day. How do those patterns evolve over time at the individual level, right? So not how is the whole community using my app, but how is this individual using my app now versus how this individual used my app a couple weeks ago or even a couple days ago. Health research. Can we predict earlier on in an experiment what's likely to happen, right? Sometimes people continue experiments for a long time, but you kind of wonder if they actually could have backtracked and figured out much earlier on, oh, you don't need that placebo anymore, let's switch you over. And empirically, we know that that's only done when the results are really, really strong, but people are usually just looking at the overall success number. They're not sort of looking at trajectories, right? So we have to wonder if these are being done as efficiently as they can. I would argue in part because they're using these sort of SQL-like thinking and SQL-like data storage formats where I'm really just looking at that final number. So I'm trying to move us to thinking about something more than who had the highest score, who had the lowest score. Similarly, consumer research. If you don't know, you probably haven't worked in consumer research, but people like different things purely depending on the order they see them in. You might show me a dress, and if it's the first thing I see, I'm like, ugh, that's a crap dress, like, I don't want that dress. If it's the fourth thing you show me, I might fall in love with it. I mean, that's just sort of how malleable the human brain is. So if you're working in any sort of field that's related to telling people what they like or figuring out what people like, you too should be paying more attention to the things ordering happens in. Okay, so I'm probably hammering this home way too hard, but I also even wanted to do a little bit of psychology about why this is so important and why I know I tended not to ask NoSQL questions all that often before, even though I had the data to answer them, and even though they are interesting if you're not the one who has to do the work. One is status quo bias. Humans tend to take whatever default is presented, right? That happens in data analysis too. So when I give you that first graph, right, that shows the tests in order, when I ask you what's interesting or what you know, you're going to go to that ordered column, right? Because that's really the easy place to know something. Endowment effect. Humans tend to want what they already have and think it's more valuable than what's offered for a trade. So have you ever had sort of the new guy or girl join your engineering team and say, oh, you guys use Postgres, well, that's interesting, but we were using Mongo, and it's awesome. And you're sort of like, I like what I've got, I like my database, like, it must be better because it's the one I have already, right? So we've all sort of gone through this. Or you join a new team, but you're still attached to your old setup, your old stack, and you have that same bias. And then this one, this is a really deep one, and you guys are going to be surprised, but this is personal field research, especially deep finding. Humans are lazy in general, right? And we are no exception. We don't want to do work that's hard work. So this is all about, like, let's just store an array in a data field rather than, tidy data. That's my initial argument. And you would say, well, that's not really NoSQL. That's just straight up pandas or data frames in R or in Python. And, you can always sort of reconstruct these trajectories. And I'm sure you guys who went to the pandas tutorial this morning have many better ideas, but when I sort of off the cuff, top of my head, think, how am I going to do this? Well, one way I think is, okay, I'm going to do a group by, and then I'm going to apply some kind of lambda function, and I'm going to sort by the day, and then I'm going to grab the score for each person. that's okay, I did it. I don't think this passes muster under PEP 80. I think that's a really long, ugly line and not that easy to think about, but I also don't even get all the data I want, right? What's something that's missing? Yeah, right, I don't actually have a day. It might be in the right order, but knowing Alan had only 2 doesn't tell me which one he missed. Kind of important. Okay, then I thought of another one, and again, I am not claiming to be a pandas whiz, but I just thought, okay, well then I'm gonna just make a new list. I'm gonna go through that tuple that comes out of the group by, and for each of those, I'm gonna sort of make a little mini dictionary and stick that on my list. Oh, well, now we're all super happy, right? This is the opposite of tidy, right? I've got a list with a dictionary inside. This is okay. At least I know sort of when Alan missed his test now. I don't know that this is especially easy to read, right? Which field was the day versus which was the score? Not easy. Not easy is really important. I think that's something I want you to take away from today. Just because you can know it doesn't mean you know it easily, right? And anything you don't know easily becomes increasingly remote, right? The harder it is to know, the less you really know it, even though it's accessible. Another one, well, why don't I just, to make it neater, I'm gonna define a function, and in this function I'm gonna sort of do some kind of row selection, list comprehension type thing, because I like really long list comprehensions. And then I'm going to have a nice little apply. Well, that sort of gets me what I want, but this is not really what Python is supposed to look like, right? We want our Python to be nice and short and expressive and beautiful, and I wouldn't say this is. And not that it always has to be, but I'm not thrilled with this. So my argument is don't store it this way, and that's part of why I want to spend the next portion of the talk saying, well, why don't we just store it originally in this format, right? Why didn't I just write down these arrays to begin with so I don't have to be going through these hoops with my pandas? Okay, but a little bit more on the why, right? Let's be honest, no one wants to be any of those processes I've just suggested, and there's obviously others like reindexing. I'm sure people in the audience have better ideas, but you don't want that to be a first step to every query you're going to make, right? Increasingly, we're going to be making these sorts of queries not about who had the highest test score or who had the lowest test score, but rather about how things happened, right? It wasn't that wasn't important in the past, but we have more and more data where we know how things happen, right? Google Ads. I feel a little less surveilled in Europe than I do back home in the States, but I think nonetheless that Google is following me around. They definitely know I'm in Amsterdam. It's almost like I get here and they're like, welcome, Aileen. We haven't seen you in 8 hours while you're on the plane. So lots and lots of time series data. Wearable sensors. This is actually something my company is working on to do with diabetes, but this is coming. People have sports clothing with little sensors. You're just going to be tracked all the time with everything, which means everything is a time series, right? Everything you do, every data point you provide or you get as an analyst is going to have a timestamp, and it's a meaningful timestamp, right? Now it's not just when the data entry clerk got to it. So the unit of observation should be the actor, not the particular action observed at a particular time. I think we need to move away from this tidy idea that what I saw at a particular moment with the person just being a variable is the way to go, and be thinking more and acknowledging more that everything is happening in some kind of time-oriented context. So we should be rethinking what we mean by observations. Okay, I also want to point out we don't look for NoSQL because we have NoSQL databases, right? So I don't think this is a case of the intern just found out how Mongo works and they think it's awesome and they want to try out this new sequence, so they're trying to cram things in, right? The point is this is all coming because our infrastructure is evolving. What we can know is evolving. It's becoming more contextual, and so for that reason, the data is going to be more NoSQL-like. So I'm not going to go through this list. I guess the ones I would highlight, though, are that the schema will be changing all the time, right? People are constantly tacking on new things as they realize they can measure them. If you have more of a SQL mindset, you're going to think, oh, no, that's another table. That's another join I need to write. That's more group by statements I need to worry about. Similarly, the patterns are going to change all the time, right? You stop recording something. You record it in a new way. You define the event in a new way. This is definitely happening where I work, where we're constantly rewriting our app in response to how users are responding to it, right? So anyone who's working in a company that does a lot of A/B testing, you know things are constantly changing, right? Your intro sequence is changing. Everything you do is changing. Okay, so what is NoSQL Python for me? I would say it's when you have to deal with sort of arbitrarily nested data. This is something you see with NoSQL, right? I can collect at any data point as much as I want to know, right? So maybe when you're wearing your sensor, first I'm just like, well, where was Joe at 2 o'clock and where was he at 3 o'clock? But then my sensor gets smarter, and now I'm like, well, what was Joe's heart rate, or what was Joe wearing, or what was Joe thinking? What was his mood, right? And I start adding fields, and I started with an array of one value, and soon I have an array of dictionaries, and soon I have an array within an array and all that. Ragged data, similarly like that, I sort of take it or I don't take it. It can be a length of 1 or 0 or 1,500. I just have no idea. But I want to be able to compare against individuals, even if I have different amounts of information about them. And that is related to comparative time series, same idea. Okay, so where do we find NoSQL data? Here's where I have found it, and this is why it's been on my mind. I found it anywhere from a physics lab to working on a running app to now I work with health data that sort of comes in when it feels like, and sometimes it stops coming in, and how do we make sense of that, right? Or Reddit is a popular example for people who read Reddit. That is highly, highly nested data, but it's also all a time series, right? Everything is coming in with a timestamp in response to things that came in earlier. Okay, so on to the how. Definitely the most boring part of the talk. If you want to go to sleep, this is the time. Getting the data into Python when it's straightforward. This is a scenario you're grabbing a bunch of NoSQL data from an API or from a NoSQL DB. I'm mostly thinking about JSON. It's a common format, especially for textual data. Best case scenario, you sort of take everything you can get. In this case, I would stick with pandas, and I just want to point out that normalized JSON works really well. Raise your hand if you've worked with normalized JSON. Oh man, so you guys all just have like data engineers who do everything for you. I see how it is. I just want you to know, if you ever don't have a data engineer to parse stuff for you and you think you're looking at something that's way too complicated, I just want to give you the good news that actually normalized JSON is like amazing. It will take care of almost everything as long as you want everything there is, and as long as the format isn't too perverse. So if you look at this, for example, I've got a Jane Doe and a Bob Smith. First thing I'll point out is I've sort of got random fields, right? So one thing has a field, the other one doesn't. Another problem, I don't just have random fields that are in one record but not the other. Some of them are arrays. Oh, well, that's wonderful. I also, this one is especially egregious, I have the same field, series. One is an array of dictionaries, the other one's just a dictionary. Oh, well, we all love coding for situations like this, right? Actually, you don't have to. If you just sort of chug this in with the normal JSON normalize, it comes out really well. It will say, oh yeah, that's a dictionary, no problem. Or that's an array of dictionaries, no problem. That's what your data field is going to be in that column. So you can mix and match. It just takes care of it. And it's also easy to add columns. So for example, I use the apply on length. That works both on the individual and on the array. So basic lesson is things have gotten developed enough. No JSON, as long as it's correct, is all that awful. And you're going to get really nice columns and everything. So basically, there's no excuse not to deal with this. There are some things you can do, right? Using some programmer stuff. I'm more on the software side than the data side, so this is interesting to me. One thing is you can subclass an iterable to shorten your apply calls. Raise your hand if that sentence makes no sense to you. Okay, so that's fair enough. I know lots of people are much more on the data end. So this basically means, like, if you use the normal list, that's fine, but you can't customize. I want a list, but I kind of want a list that does special things. And in particular, let's say I know I have a list, but I don't want to have to write out apply and a function to write the average. So instead what I'm going to do is I'm going to define or subclass under call. This is one of these functions that will come with any object. It basically just means if you take a class member and you put parens after it, you get this function, right? So I can sort of make myself a special list. It's a subclass of the Python list, and it will behave as I want, right? So if I just want, every time I put parens after my instance to get the average, I can do something like that. If you want to do this, there's a ton you can do with this. This is one of the reasons I think Python is just so well suited to this sort of data processing. I will point out you need to at least subclass get, item, and iter, those two. You should probably subclass init as well in cases of inconsistent format. So if you remember the JSON we just looked at, in one field I had both an array and a dictionary, right? If I'm going to subclass that, I'm sort of assuming I'm going to get a list, but I should probably check that I've got that list, right? So there are a couple of gotchas, but make the fact that classes are first class instances in Python and are very dynamically assignable work for you. It's actually one of the reasons Python is so great for data management. Then, for example, what I do, I don't know if this is best practice, but it's super flexible. Call can be a catch-all adjustable function, right? So sort of anything I want to happen to that data that's in my column that has now been subclassed, say as my DF list, I can keep rewriting call to do whatever I want. And then instead of those really long Python lines, telling the apply function what to do, I just put those parens afterwards, and boom, it's nice, it's short, and it's beautiful. I'll also point out that custom classes pair nicely with class methods, right? So especially when you want to be able to swap things out as you're going, right? So first I want my call to be one thing. First I want it to compute the me, and then I want it to just print out the name, whatever it is. It's very easy if you make it a class method to just swap things in and out, right? So here you can see I did that. I took test, and I actually assigned a new function to it. So if you do a lot of sort of console level data exploration, you already have a whole column subclass to some class that you fully control. You can swap out those class methods. And again, it just makes your life really easy. Okay, so getting NoSQL data, commonly encountered problems. This stuff is not thrilling, and I am going a lot slower than I thought I would. So I'm going to speed through this. Raise your hand if you have any particular questions. Weird CSV files, this tends to be things where you get an array in a CSV or some JSON. This is pretty straightforward. Usually you're just going to use regex and common Python string operations to clean up the data. Regex is never fun except for people who do it every day. Stack Overflow is a great resource. Try it a few times and you'll usually figure out what you want. Apply is your best friend, and then a couple of common problems are things like just having a space where you shouldn't. So read CSV has about 20 parameters. I can promise you whatever problem you are encountering, one of those parameters takes care of it. So just like JSON normalize is amazing, so is read CSV. So for example, if you have a CSV, it's going to look like this, and in particular, you'll see the way we put the arrays in. We actually just put them in quotation marks. This doesn't work great because it's a string, but actually you just need, I wouldn't even call this regex, just very normal Python processing to split this into an array, right? So remember the beautiful thing about Python, strings are super easy to deal with, and you can convert them to any data format you want very quickly. I'm going to skip that. It's a lot of text, funny picture. Sometimes you get JSON and you don't like the structure, right? So we talked about JSON normalize. That will get you all of the fields. If you don't want all of the fields, there's this really nice package, JQ. Anyone familiar with this? Super fast JSON parsing. If you don't know JQ, you should learn it, because what you can do is when you're reading your JSON, you can grab only the things you want. So if you really only care about 2 fields and you've got some horrible JSON that's got like 30 fields, some simple statement like this is going to get you everything. And you can also use it with the sh utility, so you don't even need to do it from the command line. Okay, sometimes you have no idea what's in an enormous JSON file. We've all had the joy of working with undocumented or inconsistent APIs. You're not even sure if the company's operating, but somehow they have some really nice data you're kind of interested in. Maybe you've inherited a legacy Mongo database. I think Mongo's been around long enough. There is some confusing legacy stuff out there. Or someone just gave you some gnarly JSON because they didn't know how to deal with it. And they were like, can you just, and then walked away. So the IJSON module is really nice. This is an iterator JSON parser. So you can go one element at a time. This also, what it gives you is a great opportunity to make data parsing decisions as you go. So as you're sort of iterating through the JSON, you can also see what it looks like. It's not going to be fast, right? This is about exploratory data analysis. This is not about processing gigabytes, petabytes of data. This is when you're figuring out what you initially want to do. You're a programmer. Use iterators, right? So the idea is with IJSON, you look at one record at a time. One thing I really like to do is I like to sort of subclass as I'm reading in the JSON. So I do this thing called recursive check. What that does is it figures out what things are sort of dictionary-like structures I might want to turn into special classes. So if it's a dictionary, I sort of look at the keys And depending on the keys, I say, did I create a class for those keys already? Boom, I assign it. If I didn't, I literally ask myself, why don't you give me a new class name and write some code, and literally I'm going to then import that code you just wrote. So you can sort of be coding for your JSON as you're going. And if I have a list, I'm going to do that for each item in the list. So basically, you can build custom classes or named tuples as you go. This lets you know what you have in your data, right? The problem with pandas, JSON normalize, is even if I sort of close my eyes, Hail Mary, I hope it will work, I don't really know how that data was structured or how many fields I was supposed to have. If I sort of iterate through it, I have a much better idea of what I'm doing. And as I discussed before, this is also, again, a great time to use your classes and dynamic class method assignment to sort of change things as you're going. Okay, so finally back to the why again. So I wanted to quickly show you some benefit you get to this, right? I've just showed you all of this boring CSV JSON parsing. Mostly told you it's taken care of, but when it's gnarly, it's really gnarly. Why might you want to do this? So one really cool thing that I'm sometimes puzzled we don't see more of is clustering time series. So like I was saying earlier, in my opinion, almost all data we have nowadays is really a time series, right? It's very rare to not have some kind of sequential data about a user, about an experiment, about whatever it is that you are measuring. So I would like to see more clustering and classification of time series, which is why I'm choosing this. It sort of looks like this, right? I mean, I think clustering of time series is intuitively just like all sorts of other clustering. The methods are computationally demanding. They're sort of order n squared formally, although when you look empirically, it's more like 10% times order of n squared, which does make a difference, right? So you're not really paying that full cost. Relatedly, classification can be used for series-related predictions, so it's not just clustering. You can also do predictions. And wouldn't it be cool to be doing a prediction per user in addition to doing all your normal SQL operations? So like I was saying, this is very straightforward. You can use many commonly applied clustering algorithms that you already know. Okay, I keep thinking you're going to ask a question. Anyway, I just want to show you a few cool examples. Anyone use the Endomondo running app? Well, you might be interested to know if you sort of look at the time series and cluster them, we've sort of got some kind of Nordic cluster going on. So Denmark, Norway, Sweden all sort of have this morning-evening pattern. And then the Baltic states are all sort of doing their own thing. I didn't select them this way. This is the result of the clustering study, right? So if we just sort of look at when these countries go running, we see some geographic correlations. I have to admit, I made these plots in R, so I'm not a pure Pythonista. This is another example. I'm just sort of using personal data I've come across. So I used to work in an nanoscale physics lab, and what we would do is we would sort of pull on molecules, and we would measure what the electrical signal looked like. And these are sort of color-coded here, but what you see is if you think about these as a time series, the time series behave differently for different molecules. And what we do is then we add these up into these two-dimensional histograms, and you can see that you have very distinct clusters of time series, in this case with a physical basis. Reddit, another example. So I sort of pulled the top 25 threads from the main page off of Reddit for a couple of months, and I looked at sort of what subreddits made it and how they tended to do. And again, I saw a great example of why it makes sense to cluster time series. In the videos over here, I don't know if it's showing up very well, but what you can see is that videos, when they make it to the top, they sort of don't last that long, but they get up pretty high, right? So the video is pretty funny. Everyone clicks on it, but I guess everyone has then seen it, so it goes away. Personal finance is really kooky because it sort of comes up, right? It starts sort of low, and it sort of disappears for a while, and it makes a comeback, right? This is the pattern for most of these time series. And then 2X chromosomes never really does that well, tends to last a little bit longer than a video. These were chosen at random. But it just shows you what you can learn from grouping time series. So quickly how it works, in case you're wondering and haven't seen it, what you basically do is you don't want to do Euclidean distance. That actually gives you some really crap results. What you do is you sort of figure out what's the best fit of one time series to another so that you are controlling for offsets, right? Offsets aren't really that meaningful. What is meaningful is how the shape matches. The way you do this is you compute a distance matrix of each point against each point. You put in some sort of common sense band, and then you find your minimum distance path through that matrix. This is a dynamic programming problem for those of you who are more on the programming side. Not terribly difficult, but it can be computationally taxing. However, in theory, what I was mentioning before, right, it's order n squared in theory. In practice, even if you don't put in a lower bound, you're only at about 10% of n squared, and more often you're at like 1%. Why do we need the fancy method? If you just use Euclidean distance, this red straight line ends up looking more like TS3 than like TS2, right? So you end up matching a straight line to a sinusoidal curve. Similarly here, if you do Euclidean matching, you can sort of see you get some weird clustering. You really want to stick with that dynamic time warping, which is what I was mentioning. And then this example, I actually pulled off a .nl blog, and this is somebody clustered the time series, clustered the time series for bike stands in Washington, D.C. So I don't imagine the author is here today, but it's a pretty cool blog post. And it was just one example of what I was able to find other people doing, right? So in addition to thinking about where things are or how much they cost or any sort of SQL-like thing, you also have this whole new source of data based on treating time series like a characteristic rather than just a time series as something that doesn't talk to SQL data. Just some future research possibilities that have been proposed. They're sort of text recognition, movie analysis, image recognition. I'm just throwing that out there. Not too related to the NoSQL. But this is my final argument for what I'm calling NoSQL Python, right? Once we start putting these arrays in and realizing that a time series is a characteristic, not just a time series, this opens all sorts of novel ways to think about data and novel questions to ask. So the very short version, skipping the boring JSON parsing, Pandas is already well adapted to the NoSQL world. It might not be super efficient for these sorts of operations. That's not what it was built for, but you can do anything. You can stuff any sort of custom object you want. Make your data format work for you. Remember that you are lazy. That is just sort of normal, but since you're lazy, you want your data to be in a format that makes the interesting questions easy to answer. Comparative time series go hand in hand with the increasing availability of NoSQL data, so I hope more people will start realizing that these time series you have about all your internet users, all your game users, all your patients in medical studies, it's almost like a whole other dimension of data that's drastically underused. And similarly, just like we saw talk about recommender engines earlier, even data that is not sequential but grouped has interesting things you can do with it. So that is my talk. Thank you.
Questions?
Thanks for your talk. Just a practical one. Is your presentation available on GitHub?
Not yet, but it will be.
Okay, thanks.
Yeah, just a quick reminder, we'll try to post a presentation along with the YouTube videos in 2 weeks or something. So, other questions? I do have one. Does the time series recognition works good when you have mostly small discrete jumps, so it mostly look flat most of the time, it jumps up and down? Or
so you certainly, if you have more features, it works better, but it's amazingly robust, and some other things that are interesting I didn't get to mention. You can compare time series of unequal length, and that works extraordinarily well. You can compare sort of subsections and find motifs, but definitely the more features you have, as with all data, feature-rich data is much more reliably classified.
Have you used that for also time series anomaly detection?
I have not personally, but I think it's a great idea, right? That's a whole other set of categories. Again, I can add to an individual or an experiment.
well, let's thank Aileen again then.
Okay, thank you.